Right, welcome to Mr. H's Cram Notes 1.1 System Architecture, where I'll try and get through things as quickly as possible. This is a no frills, no bells presentation detailing all the key points of the syllabus for System Architecture from GCSE OCR 276. The purpose of the CPU. Alright, the CPU stands for Central Processing Unit. The purpose of the CPU is to do three things. One, to fetch instructions from primary memory. 2, to decode the fetched instructions, and thirdly, to execute the instructions and possibly update primary memory. Right, so here we have a very basic von Neumann computer model. We can see that the model has an input, outputs, and in between the input and output we have a processor. The processor is connected by a single busing system to the primary memory, which holds both data and instructions. This is also known as RAM, or random access memory. Secondary storage is non-volatile memory, which is designed to go for much longer, keep things much longer. And the primary components within the CPU are the ALU, the CU, the registers, and the cache. Here we have a more zoomed in, updated view of the CPU vis-a-vis the von Neumann computer architecture, and we can see that the main components are shown. The arithmetic logic unit, responsible for doing arithmetic and logic calculations. The control unit, responsible for controlling and the flow of instructions around within the CPU and to main memory. And there are a number of other important things to notice. There are in fact three main buses: a bidirectional bus for the data bus, which moves data to and from the CPU and primary memory; the address bus, which looks up the address of either an instruction or a piece of data; and the control bus, which is linked to the control unit and the clock, which determines when the CPU can do its read-write to RAM, so it doesn't hit one of the RAM's refresh cycles. There are a number of other little components called registers. The registers are very specialized high-speed memory locations. You need to know the following main registers as part of the architecture: the accumulator, the MDR, the memory data register, the MAR, the memory address register, and the PC, the program counter. Briefly, what do these guys do? Right, the accumulator behaves both as an input and output of the arithmetic logic unit. It's an input and an output for the accumulator. The MDR, memory data register, holds or buffers either data or instructions read in from the primary memory, or data waiting to be written back to primary memory. The MAR, memory address register, holds the address of an instruction to be read that is about to be read on the next read cycle, or a piece of data that's about to be read on the next read cycle, or an address to update in primary memory on the next write cycle. The program counter, the PC register, holds the address of the next instruction to be executed. The IR, the instruction register, holds the opcode, the binary operations code of the current instruction being executed. Right, so now we'll return to a close look at the 3 or 4 main components within the CPU as to their role and function, beginning with the ALU. The ALU stands for Arithmetic Logic Unit. It performs all arithmetic or mathematical calculations like addition and subtraction. It also performs logical or Boolean true or false calculations, for example, equal to or not equal to. An actual OCR question: what is the purpose of the ALU? The actual answer given by the ALU: arithmetic and logic unit used to perform arithmetic calculations, example add, subtract, multiply, comma, used to perform logical operations, example less than, greater than, equal to, not equal to. Right, the second CPU component and its function, CU, the control unit. The control unit is responsible for fetching, decoding instructions and managing the flow of instructions and data within the CPU and between the CPU and RAM. Actual OCR question. What is the purpose of the CU, the control unit? OCR answer. 1. Controls the flow of data within the CPU, that is between the registers. So it will control how the data and instructions move between the various registers, the MDR, MAR, accumulator, and some general purpose data register, as well as the PC and the IR. Next possible point to the answer. Controls the input and output of data to or from the CPU. Right, it does this by controlling the control bus, as well as making sure the MAR and the MDR have the correct data loaded for either a write or the MAR for the correct read. Point number 3, controls the timing signal sent within the CPU itself. All the operations within the CPU are orchestrated by a clock. So to give an example of how that would work, on one little clock tick, the input A and the output from the accumulator would be gated into the ALU. A clock tick would go by, and then the final, after things are stabilized in the electric circuit, the value would end up in the accumulator. Time would be allowed for that to stabilize, and then the results of the accumulator would be sent either to the MDR, the memory data register, or some other temporary address. What is a register? A register is an extremely efficient on-chip memory for handling short-term memory used to store addresses, instructions, or data currently being worked on. There are 4 registers that you need to know the names of and their function. The ACC or the accumulator. The accumulator is used to store the value of the currently being worked out or worked on instruction, as well as the result of the last calculation. So you can see the accumulator is both an input to the ALU as well as the primary output to where the output of the ALU goes. PC stands for program counter. This stores the address of the next instruction to be executed. The program counter stores the address of the next instruction to be executed. It is in turn therefore hardwired to the MAR, the memory address register, so that it is capable of loading the next instruction when the next read cycle is performed. The MAR or memory address register. This is used to store the address of the next instruction or data to be accessed, either by reading or writing. And finally, the MDR, memory data register, is used to store the data to be brought from or sent to main memory. The program counter is used to store the address of the next instruction. Right, CPU components and their function. The cache. The cache stores frequently used instructions and data. Second point is built into the CPU, so we're talking in this day and age primarily level 1, level 2 cache. And 3, provides faster access than RAM because it's built on SRAM, static RAM, as opposed to the slower dynamic RAM that primary memory is composed of. It allows instructions and data to be loaded into the CPU more quickly. This is so because large and frequently used instructions and data can be stored in the cache, which doesn't have the restriction of a read-write cycle and refresh cycle, whereas primary memory does need to have a refresh cycle. This is what slows down the system. What is the function of the CPU as a fetch execute instructions stored in memory? Actual OCR question. What is the function of the CPU? Alright, I've got the question mark over there. Answer: to fetch, decode, and execute instructions. You need to know how the common characteristics of CPU affect their performance. This includes clock speed, cache size, and number of cores. How does OCR question: what are the effects of using a processor with faster clock speed? Answer: more instructions can be carried out per second, and so instructions are executed more quickly, which in turn allows for more programs to be run at the same time, which in turn allows more complex processes, for example 3D graphics, to be completed in real time. Cache size. OCR question: what are the effects of using a processor with a bigger cache? Point 1. More space for frequently used instructions and data. So the bigger the cache, the more instructions and data you can store in this much faster cache. More storage for very fast access, which in turn means faster fetching of instructions, so faster processing, in other words, which means faster fetching of data, and so in turn faster processing overall. In other words, the whole fetch, decode, execute cycle is much faster because you're not waiting for slower RAM for frequently used instructions or data. How does the number of cores improve CPU performance? Actual OCR question: what are the effects of using a processor with more cores? Actual answer: well, the more instructions can be carried out simultaneously because each core has an independent data path. The processor can process more instructions at the same time, obviously because you've got two data paths and therefore two cores doing instruction processing at the same time, which allows for batches of instructions to be executed more quickly because the two cores can tag team on which instruction is done, or one can focus on one particular aspect of a program or another thread or whatever the case may be, which in turn allows for more programs to be run at the same time, but also not only more programs to be run at the same time, but also allows for more processes or sub-processes within a program. For example, something called a thread, more threads to be run simultaneously. Right, embedded systems. What are embedded systems and what is the purpose of them? Actual question: what is meant by an embedded system? Official answer: a computer system that is built into another device and add as part of a larger complete system. Actual question: what is the purpose of an embedded system? Right, OCR provides two official answers. 1, to provide a specific predefined function which is cheaper than providing a personal computer. Alright, a specific predefined function, in other words, and it doesn't include unnecessary features which makes it smaller than a PC, allowing for the device to be automated or programmed. Argue also making it more memory and cost efficient as well as energy efficient. That concludes section 1.1 on system architecture. I strongly recommend you turn all these official questions and definitions into cards, learn them, learn the diagrams, and practice the worksheet that I will attach to this video. Thanks for watching. Mr. Holmes signing out.